Very good evening to all. Today we'll discuss normalization topics in DBMS. So why we require normalizations? So normalization is used to organize the data properly and avoiding completely problems in a database. Completely we are organize the data in a proper way, avoiding complete problems like reducing the data redundancy, duplications, avoiding the data anomalies. Anomalies will be different types of anomaly: insertion anomaly, deletion anomaly, updation anomalies. So to improve the data consistency, to save storage space, to improve the data integrity. So these are the reasons we are using the normalization concept. So mainly for organize the data in a proper manner. So completely saving the storage space, improving the data integrity, and avoiding complete data anomalies, reducing the data redundancy. So what is so based on the normalization, there are different normal forms. First normal form, second normal form, third normal form, fourth normal form, fifth normal form, and Boyce code normal form. So today we'll discuss first normal form, second normal form, and the third normal form. So first normal form, the rule is no repeating groups. So that means no multi-valued attributes. Each cell should contain only one value. So that is each cell should contain only one value. They should not have any multi-valued attribute. So here phone number has a multiple values. You can see here two phone numbers. So how to decompose this table into a first normal form? Again, we are creating one more rows. Then we are adding the second phone number. So this is like a first normal form. So now we'll discuss about the second normal form. So second normal form, the rule is it should be in the first normal form. So that means there is no multi-valued attribute. Each cell should contain a single attribute. So then second rule is no partial dependency. So we already discussed the fully functional dependency. So that means all the non-key attributes are fully functional on the primary key. So all the non-key attributes should be fully functional on the primary key. There is no partial dependency. No attribute should depend on the just part of the composite primary key. So we are mainly this applying only when there is a composite primary key. So this is an example: enrolling student ID, course ID, student name, and course name, grade. So here in this table, there is a composite primary key, student ID and course ID. So here, so primary key is student ID and course ID. So what are the main dependencies? Student ID is depending on, student name is completely depending on student ID, and course name is completely depending on course ID. So, but the grade is completely dependent upon the student ID and course ID. So here, as per second normal forms, there is no partial dependency. So that means student name and course name depending only on the part of the key. So they are not depending the fully functional. So it's depending, it's like a no partial dependency. So here student name is only depending on the student ID. So here primary key is student ID and course ID. So in this table, it's a composite primary key. So only in this grade is completely depending on the student ID and course ID. So how to convert this into second normal form? We have to decompose into three tables: student table, course table, and enroll table. In the student table, student ID and student name. So here the non-key attribute is completely dependent on the is primary key, student ID. And when it comes to course table, the non-key attribute is course name is completely dependent on the primary key of course ID. And in the enrollment table, the non-key attribute is grade is completely depend both the student ID and the course ID. So that means no partial dependency. So this is student table conversion, course table conversion, and enrollment table conversion. So now we'll discuss about the third normal form. Third normal form means it should be in the second normal form and there is no transitive dependency. So when it comes to second normal form, we used to tell it should be in the first normal form. There is no partial dependency. Non-prime attribute should not depend on the another non-prime attributes. So every non-column should depend only on the primary key, not the other columns. We're taking the student table, student ID depending on department ID, department ID depends on department name. So there will be an indirect dependency of student ID and department name. Student ID depending on department ID, department ID depending on department name. So indirectly this student ID is depending on the department name. This is called transitive dependency. So third normal form does not allow this. So transitive dependency means A implies B, B implies C. So A is indirectly depending on the C. So how to split this table? Student is a table 1. We have to, in this table, we have to give only student ID and department ID. Second table, department table, we have to give department ID and department name. So there is no transitive dependency. So we will compare the first normal form, second normal form and third normal form. First normal form is no multi-valued attribute. Each cell should contain only one value. So it is the rule is atomic value. The problem we are removing is repeating data. So multi-value data. Second normal form, the rule is no partial dependency. So they're like full key dependency. So problem we are removing is partial dependency. Third normal form, no indirect dependency. That means no, there is no transitive dependency. Thank you.